All right, let's get into it. Today, we're cracking open the ultimate rulebook for the entire universe. It's called thermodynamics. And these aren't just theories. These are the hard and fast laws that control absolutely everything, from the coffee on your desk to the stars in the sky. And it all starts with a question you've probably never thought to ask. You know how a hot coffee always gets cold if you leave it out? Well, have you ever seen the reverse happen? Have you ever seen a cup of cold coffee just start heating itself up? Of course not. It sounds ridiculous. So why is it a one-way street? The answer is hiding in these fundamental rules. Now, I know the word thermodynamics can sound a little heavy, a little intimidating, but don't worry about that. Just think of it as a set of a few really simple and totally unbreakable rules for energy. It's the universe telling energy what it can, and more importantly, what it can't do. At its heart, that's all it is. The science of how energy moves around and changes form. And these aren't just suggestions from a textbook. These are cosmic laws that apply everywhere and to everything, from the engine in your car to the fiery heart of a star. No exceptions. Okay, so let's jump into the first rule. It's the most famous one, and there's a really easy way to remember it. You can't win. That's it. You just can't get something from nothing. This is what scientists call the conservation of energy. It means the total amount of energy in a closed system, like, our entire universe, is always the same. It can change shape, for sure. Chemical energy becomes heat, heat becomes motion, but the grand total never ever changes. It's like a perfectly balanced cosmic bank account. And this law is the reason why the dream of a machine that runs forever without any fuel is just that, a dream. This idea, called a perpetual motion machine, would have to literally create energy out of nothing to work. And the first law tells us, flat out, that's impossible. This quote really nails it. The universe doesn't do freebies. To get any work done, to make anything happen at all, you have to put energy in first, every single time. It's the ultimate no free lunch rule. But hang on a second. This brings up a really good question. If energy is never destroyed, if it just changes form, then why can't we just recycle it perfectly? Why can't we build an engine that turns every last drop of fuel energy into useful motion? Well, the first law doesn't have the answer. For that, we need the next rule. So let's move on to the second rule, which is honestly even more fascinating. The first law said, you can't win. Well, the second law says, you can't even break even. Not only can you not get something for nothing, you always lose a little bit of what you have. See, the first law is great, but it has no sense of direction. It wouldn't have a problem with a cold coffee sucking heat out of a room to get hot. The energy would still be conserved. The second law is what puts the arrow on time. It's the one-way sign for reality. It tells us which way things are actually going to go. And here it is in action, plain and simple. Heat naturally flows from something hot to something cold. It's trying to even things out. It never goes the other way on its own. And that right there is why your coffee cools down. It's just following the law. Now, this leads to a more formal, sciencey sounding version of the rule. But all it's really saying is that you can't build an engine that's 100% efficient. You can't take heat and turn all of it into work. You always have to dump some of it somewhere colder as waste heat. You can't break even. So why? Why is there always waste? Why is it a one-way street for energy? The reason is one of the biggest, most important ideas in all of physics. And it has a name: entropy. Entropy is just a fancy word for disorder or randomness. Think about it. A neat stack of papers has low entropy. If you throw them up in the air, the scattered mess on the floor has high entropy. A tidy room is low entropy. A messy room is high entropy. It's that simple. And here's the kicker. The second law is really just saying this. The total amount of disorder, of entropy in the universe is always going up. Things naturally fall apart. They go from ordered to disordered. This steady march towards chaos is what gives time its direction. It's why we see things break, but never unbreak. You can see this everywhere. You have a solid ordered ice cube. It melts into a disordered puddle of water. Two gases in separate jars, they'll mix together into a random jumble. And that hot coffee? It doesn't hoard its energy. It spreads it out all over the room, increasing the overall disorder. All of these are just entropy in action. So these rules sound kind of huge and philosophical, right? But engineers rely on them every single day. They are the absolute foundation for how we design pretty much anything that generates power. Your car, a jet engine, a massive power plant, they all have to obey. Let's just quickly look at a power plant. It's basically a big loop. First, you take water and put it under a ton of pressure. Then you use heat to boil it into super high energy steam. Next, that steam blasts through a turbine and makes it spin. That's what generates your electricity. But here's the crucial part. To start the cycle over, you have to cool that steam back down into water. And that's where you dump the waste heat, just like the second law says you must. And look at the breakdown here. You put in 100% of the energy from your fuel source. A really, really good power plant might turn about 40% of that into electricity. So where does the other 60% go? It's gone. Lost is that unavoidable waste heat. That's the tax that the second law charges on every single energy conversion. And it's non-negotiable. So let's wrap it all up. What are the big things to remember? Number 1, the first law. You can't win. Energy is conserved. Number 2, the second law. You can't even break even. The universe always gets messier. And number 3, the result of all this is that no engine can ever be perfect. Turning heat into useful work always has a cost. And that leaves us with one last massive question to chew on. If the whole universe is on a one-way trip to total disorder, then how in the world does something as beautifully complex and ordered as life even exist? How do we build pockets of incredible order in a universe that prefers chaos? Well, that's a puzzle for another time. Thanks for joining me.